an oscillator or clock stage, a memory circuit which stores digital function codes, a serial pulse output stage, and a power control section. When a function button is depressed on the infrared-style remote control, the keypad decoder section will trip the power on, starting the internal clock and accessing the memory circuits for the digital pulse code of the chosen function. The digital pulse code is clocked out of the memory circuit and into the serial pulse output stage. The serial pulse output stage assigns a certain timing duration to each binary logic condition within the function code. The serial function code is unloaded from the chip to a general-purpose transistor which drives or switches in power to the IR diode. After this cycle is complete, the power automatically trips off to extend battery life. As you may have experienced, many infrared remote control units will not operate any other pieces of electronic equipment except for the model they are matched to. This is not only due to the various digital codes assigned to each control function by different manufacturers, but also to the different timing rates of binary pulse conditions which various control units transmit. The two major problems a technician will encounter with TV remote controls are low or dead batteries and dirty contacts within the keypad. Both will make the operation of the remote control system seem sluggish or faulty. At this time, we will pause for a short review of the material just discussed. In the older television remote control transmitters, aluminum rods would be tuned to generate a specific ultrasonic frequency, ranging from 19 kHz to 45 kHz. The acoustical electronic remote control uses a Hartley oscillator or similar circuit with capacitance added to select an ultrasonic frequency which is transferred through a capacitive speaker or transducer. Infrared remote control units are essentially digital devices. Inside the IR control unit will be a small chip which controls the transmission of a coded pulse train of infrared light which represents the selected function to the television receiver. This pulse train may differ from other models in the aspects of actual code used, including the bit word length and the timing duration of each binary logic condition. This concludes review number 5. At this time, you should stop the video and complete section E in your student workbook. The final portion of this video will focus on how the television set receives and acts upon the remote control signals. Most modern television sets designed with remote control functions will contain 2 additional stages in the TV block diagram. These are the remote control receiving amplifier string and the decoding section. You will find that the older television sets will contain yet another stage, which consists of an actuator system used to physically move the controls within the television receiver. For example, when ultrasonic systems are used in the older television sets, a transducer will serve as a microphone. A high-gain amplifier is then used to boost the sound picked up from the microphone. If the gain of this amplifier string is set too high, distortion occurs and false signals may trigger one of the unselected functions within the television receiver. In other words, the television receiver may not respond correctly to the command given by the ultrasonic transmitting unit. If the gain is set too low, some of the functions may not work at all. As you can see, the correct gain setting is very important for the proper operation of the remote control system. Now let's see how this system works. The amplified signal travels from the high-gain amplifier string into a decoding section. The decoding section consists of tuned circuits which respond to the proper ultrasonic frequency of that particular remote control function. When one of the tuned circuits is activated by